Hi guys, I'm going to do a little video about the material that we covered in the previous classes. So this is about vector projections or taking projections along x and y directions, or you can call it x and y components of a given vector, right? Taking x and y components of a given vector. So I'm going to take a mass, can be a box, and it is sitting on a flat surface, and I will pick couple of forces. First F1, and making an angle 60 degrees with the x-axis, positive x-axis. As you can see, this is measured in the counterclockwise direction. And then the second force is perpendicular, and I am drawing this and I am going to color that so it is obvious to you, and I call it F2. And then the third force, I'm going to call this as F3. And F2 and F3, these are like, some special forces. We will discuss those when the time comes. And F3 force, as you can see, straight down, and the angle in counterclockwise direction is 270 degrees. Now I am going to give you some values for these F1, F2 and F3. Let's say F1 is 10 newtons, F2 2 newtons, and F3, let's say 5 newtons. Okay, I just took these random values, random numbers, and I'm going to show you how to get the net force or the magnitude along x direction and the magnitude along y direction. Now I mentioned this in the class as well, so I am going to set up a table, and in this table I include the forces, and this table will give me the net x force. Therefore, I call this axis as my x direction, positive x direction. And I'm going to mark F1, and I'm going to call it F1x. And the second force, F2x. And then the third force, F3x. So F1, you remember how to take the components at this point. So F1 is 10. So I'm going to write the magnitude first, and if you write the unit along with that, that's fine. And as you can see, F1 is making an angle of 60 degrees. So we know that x component always goes with the cosine, especially when you measure the angle with respect to the positive of x-axis going in the counterclockwise direction. Cosine 60, check it out, you will get a 0.5. So you have 10 Newton times 0.5, and the result is 5 Newton. And then the second vector is F2. F2 is 2 newtons. So here we go, 2 newtons, cosine, and the angle is 90. Cosine 90, if you use your calculator, you will see it's a 0. So 2 times 0 equals to 0. So as you can see, and as we expected, any force that points along the direction, like along the perpendicular direction, they do not contribute to that component. There's no x component because F2 is perpendicular to the x-axis. And then the last is 5 Newton force, and that's F3, and F5n cosine, and that angle is 270. Again, if you look at the x-axis, that is perpendicular to the x-axis, and if you use your calculator and check this out, you will see that the value for cosine 270 is 0 again. And this also gives us no contribution along x direction. So once you have all these things set up, what you do is you get the sum of these forces, and that is what is called as sum of F along x direction. So let's sum them. I am going to write this for, like, when you read this or when you check this out, you will know what I have done here. So I am repeating these F1x, F2x, F3x. I am rewriting it on the line, and now I am going to substitute for those, and here you have a 5 Newton, and a 0 Newton and a 0 Newton, and the sum of Fx is going to be 5 Newtons. And that is the net force along x direction. Net force along x direction. As I mentioned in the class, once you set up the x table, setting up the y is pretty easy. All what you have to do, again I repeat, when you have all the angles measured with respect to the positive x-axis and in the counterclockwise direction, this is pretty straightforward, and this is my y-axis, and I'm going to have the F1 along y direction, F2 along y direction, and F3 along y direction. And since we have everything here, as I mentioned, all what you have to do is change the cosine into sine and rewrite everything. And then 10 Newton, and sine 60 is roughly 0.86, and there you will have 8.6 Newton as the y component of the F1 force. And then F2y, you will see that magnitude is 2 and sine 90. Sine 90, maximum value you get there is plus 1. 2 times 1, that gives us 2 Newtons. I forgot to write the Newton here. You can add that if you want. And then the last force is 5 Newton and 5 Newton and sine 270. And this is the minimum value of sine, and there you have a negative 1. So 5 Newton times minus 1, and that gives us negative 5 Newton. Now again, if you want to get the sum of these these forces, what you do is add them up, and that is what is called as sum of Fy. And I am writing again for you to understand this better: F1y, F2y, and F3y. And let's put everything like, the numbers that we know: 8.6 and plus 2 and minus 5. And don't forget, this is a force, therefore the unit is Newtons. And if you get the values here, you will have 5.6 as the final answer. So that's how you get the x and y components. And there you have the sum of y. Now when we extend this further and apply Newton's laws, we need to get the sum of Fx equals to mass times Ax. And if you know how to set up these tables, and if you know how to get the x and y components along the x and y components of all the forces, then you are pretty much all set, and using Newton's laws should be very straightforward for you. But one thing to remember, that the A, which is also a vector, also has a component. So if the object is moving along x direction, you will have Ax equals to A cosine 0. Because A also is a vector, right? So you will have to take the components of vector A as we need. So here I am just going to substitute our Fx and Fy values here. There you have 5 Newton, and this side you have mass times Ax. So if you want to find the x component acceleration, let's say it is not given, then in a time where the mass is given. So let me assume the mass equals to 2 kilograms, the correct SI units. So you substitute mass as 2 kilograms on the left hand side. So you will have 5 Newton divided by 2 kilogram. They are both in SI units, so you will end up with the x component acceleration, Ax, equals to 2.5 meter per second square. Right, I just took an example here, and I made up these numbers, made up these values. So here, this is how you find the x component of the acceleration if the mass is given to you. Okay, and the same way you can find the y component acceleration by using the value that we obtain from here and substituting it on the left hand side of the second equation. Let me separate the two, and there you have 5.6 newtons, and mass is again, let me actually use it as m here for now and divide both sides by m, and there you go, and this m cancels out. If I use m equals to 2 kilograms again, there you will have 5.6 newton divided by 2 kilogram, and that will give you the acceleration along y direction. And let me write down the answer. Ay equals to 2.8 meter per second square, and that is the y component acceleration. So the problems that we are going to discuss in the next couple of classes, there we will be using Newton's laws along x and y directions. Now, as the very last part of this video, if I ask you to find the magnitude of the acceleration, then you are following what we discussed earlier. A equals square root x component of the vector square that, and the y component of the vector square that. So I'm not going to use my calculator and do all the math, but I'm just showing you what to do. 2.5 square there, and then here you have 2.8 square, and square them, add them, and take the square root, and there finally you will end up with the acceleration, a value, and with the meter per second square. And just let me quickly go over the direction of the acceleration. In order to find the direction of A, there you have theta equals, theta is the angle with respect to the x-axis, ay over ax. Okay, so you can substitute and use the calculator and check if it is in degrees or radians. It doesn't really matter what unit that you are giving the answer, but you just have to know what you are dealing with. Ay is 2.8 meter per second square, and ax equals 2.5 meter per second square, and you can find the answer for theta in degrees or in radians. It doesn't matter. So let me click that. There you go.